It's recording, and I'm mispronouncing. Okay. So, away we go. 3.2 revisited. Now this is from 3.2, a few things. First of all, evaluate the following expression using the simplest method possible. State the reason why you can use a shortcut. I look at this expression, I see the limit of h approaching 0, and then 2 of 3 plus h, all cubed. 2 times 3 cubed, all over h. I was thinking, I could work that out, but boy, I hate working out cubes. And I'm telling you, there's a shortcut. What do you recognize about this expression here? What does it look like? The definition of? It's evaluating a derivative, right? However, it didn't say you had to use that. I'm actually telling you to use a quicker method. What would the function have been here? What's the f of x plus h part? In this case, they've got the number in. Well, what's the y equals? Yeah, like that's what I'm saying. Oh, no, this is with the 3 plugged in. The x value is 3. So let's just get a few things down here, though, okay? This is the definition of a derivative, right? At the point where x equals 3. It looks like that's the thing I've changed, f of x plus h. Well, here it's 3 plus h, right? F of x, well, that's f of 3. This is the definition of a derivative when x equals 3. So, what is the function probably then? Just by looking at what's repeated on the numerator. What does it look like the function is? 2x cubed, because this is 2 times something cubed minus 2 times something cubed. Does that make some sense? If you see something that's repeated, scratch out what's changed each time, right? The x plus h and the x. You see it's 2 something cubed minus 2 something cubed. So the function must have been f of x equals 2x cubed. That's the something. I think you can do the derivative. You're telling me it is? 6x squared, great. So f prime of x is equal to 6x squared. And this means that evaluated at 3, f prime of 3, the derivative at 3, which is what this is, big expression, would be 6 times 9. It's 3 squared. So this is equal to 54. Now, do you guys follow this logic? Because I made sure I went over beforehand. Remember what the definition of the derivative is? You will see multiple choice questions often, every like 50-50 chance on a given year, that you'll see something like this. It'll be A, B, C, D. It'll have 54, 12, and some other things in there. So if you hadn't seen this before, you might be like, what? Oh, once you see this, it's the definition of the derivative. Why do the actual limit when you can just, you wouldn't need the explanation there. It's multiple choice. You say, it looks like 2x cubed, so 6x squared, 54. You'd be able to do that, I think, in less than a minute, if you've seen it before. So I'm going to scooch up a little bit. The actual part from 3.2 that I'm revisiting, the previous section, right, is this continuity stuff and, well, Theorem 1, differentiability implies continuous function, continuity. So let's take a look at this example here. And I didn't want to do it before because we didn't know how to do derivatives quickly, right? This whole x cubed's derivative is 3x squared stuff. So if the function f has a derivative at a, this case 1 maybe, then f is continuous at x equals a. Now, x equals 5, or whatever number we're talking about. So here's an example question. If I give you this piecewise function, let f be the piecewise function above, which statement would be true? Well, let's see. What does this mean? This is the definition of the derivative, but from the which side? The left. The left derivative. That means this category, right? Can you do this derivative? If it was only this expression, 3x minus 4, you'd definitely say, oh yeah, the derivative is 3, right? Because this 4 would zero out. It's a constant. But there's something about this. Does this left derivative exist?
No.
Why not?
It's not x is less than or equal to, it's just like
Yeah. Because of this, x is less than 1. It doesn't include the number 1, so you can't take the derivative at 1. And that's what this is trying to do here, right? There's the 1s there. So, this doesn't work. This is wrong. Which of the following are true? Well, that's wrong. You can even try it. And I'll just show it only for, if you're not convinced, like, what does he mean? Well, if you actually tried this with the definition of the derivative, the function at 1 plus h, h is on the left side of 1, right? So it's you would actually use this portion of it. So you could say, well, this is equal to f 3 times 1 plus h. We'd plug that in there because that's to the left of 0. The h is like negatives, stuff like that, right? Minus, what is f of 1 though? This part. You'd use this category, right? So what is f of 1?
3x minus 5.
So 3 times 1 minus 5. Oh, I forgot a minus 4, didn't I? Yeah, sorry. Start talking to me about these things. So, minus f of 1. F of 1 is equal to, like you said, 3 times 1 minus 5, which is negative, which? Sorry? Negative 2? Okay. Yeah, negative 2. Here, I was busy thinking of something here. Anyways, so we'd actually add 2, right? Minus negative. Okay. All over h. When you try to simplify this, what happens here? Oh, I forgot the limit notation, didn't I, too? That's me. My bad. Now, I'm going to run out of space. You didn't have to do this, but I want to show you. This is 3 when you distribute, right? 3h minus 4 plus 2. Yeah, question, where did I make my mistake?
The one we're using only the left limit, right?
We're using the left. 0 is approaching from the left.
Of the piecewise, the top one. Because in your f of x, I think, didn't you just use the 3x minus 5?
But f of 1 is the actual value of 1. There's no variable in that, right? So the only way you can evaluate 1 is here. Yeah. So, I see what you're saying, and that's where people get confused. So where was I here? Oh, yeah. If you distribute stuff like this, you got 3. I'll just do the numbers. Plus 3h, right? And then the 3 minus 4 is negative 1. So negative 1 plus 2 is 1. So you have 1 plus h. Agreed? Or 1 plus 3h. My mistake. Plus 3h, still over h. Is there any way that this can be evaluated? Yeah, well, 1 over h plus 3h over h. So it'll be what? 1 over h as h approaches 0 on the left. grab that. That's going to be negative infinity, isn't it?
Zero at the bottom.
It's undefined, right? Like, because you got 0 at the bottom. There's no way out of this. Can't do it. So it's definitely not equal to 3. It's an undefined expression. Negative infinity to be more specific. Now, we could establish that right away because you don't actually need to do this every time you see one of these, because it's not included in this category, right? This is from you have two different categories. That's basically, as soon as you see that it's not included on the left side of the derivative, you can't do it. Can you do it for the right side, though? You actually can, because the 1 is included, and we're talking about 0, adding 0 just slightly higher than 0, so 0.01, etc. You're going to have those kind of things inserted in there, like 1.01. That's fine. That still uses this category. So when you do this, the derivative is equal to 3. So this one's true, because it includes it, though. Do you guys see the difference there? And you could work it out if you want, using this same method. I just want to show you that the first one is a dead end. It's undefined. This one is a 3. F prime of 1 is equal to 3. Is that true?
Not for both.
Not for both, so it's not. If the left and the right side derivatives don't equal each other, it can't be true because 1 is not true. So then, of these 3 statements, only 2 is correct. But this is something, it's not continuous, basically. At x equals 1. You see that if you were to graph those, there'd be 2 parallel lines, basically, separated, right? It'd be sort of like 3x minus 4. A circle, and then, right? There'd be a jump like that. From -1 to -2 would be what the graph would look like, okay? So, questions about that? How about this one real quickly? Theorem 2, intermediate value theorem for derivatives. Okay, what was that all about? It said, and we saw this before, but it didn't make as much sense maybe. We'll keep looking at it. If A and B are 2 points on an interval in which f is differentiable. Differentiable means it's continuous and no corners or cusps, right? Then f prime, the derivative, takes on every value in between f prime of A and f prime of B. It just means as long as it's continuous and differentiable, you know the low value is 5 and the high value is 11, there must be 6, 7, 8, 9. Every value in between should be represented somewhere on that graph. Now let's take a look here. A differentiable function, some function of x, y equals f of x, has the following values for the derivative. F prime of -1 is equal to -1. F prime of 1, the derivative at 1, is equal to 1. Which of the following could be the graph of, not the function, but f prime of x? Do you notice that? So which could be a graph of the derivative? Well, we'll take a look at the 2. F prime of -1 is equal to -1. So that means on the derivatives graph, -1 comma -1 should be there, right? -1 comma, that's here, right? And 1 comma 1, that's here, yep. Does that work for this one? Yep. That's true too. So those 2 values are there. Which of the following could be a graph? Maybe both, maybe neither, maybe one. What does it state here then? Because we definitely know that this criteria is matched on both. Take a look back though. If it's a graph of a derivative that was differentiable, then f prime takes on every value in between, f prime of A to B. One of these isn't. Why?
Second,
Second one, which?
the down.
Yeah, what about it?
It's not continuous.
It's not continuous. That's right. So basically, does f prime take on every value in between the y value of the derivative, you know, the derivative's value on the y-axis? Here, from here to here, from -1 to +1, every value is represented. Here, there's a huge gap, right? In between -1 and +1. This can't be it. That can't be, because it's continuous. Right? So this is a yes, this is a no. Could be. So we could just say underneath it. Could be a graph of f prime of x. Since all values are in the range, okay? This one's not possible. You could have even had, though, like if this is -1 and this is +1 here as dots. Could this one be? Yeah, why not? I'd like to argue with you. Rashad keeps giving answers, so.
No, I honestly don't know. I thought it did. but then-
It's continuous, right?
Yeah.
But more so, does it contain every value in between -1 and 1? It has every value, sometimes more than once, right? Actually, all of them more. Yes, it does. This could work. It doesn't say it's at least once. It could have it many, many times. And it even goes beyond that. Like, you know, it goes, like, when you say it goes back, is that to the left, you mean, or?
No, yeah, cross
Oh, that's just sloppy drawing. Okay. I didn't mean it. Like, if I had it more like this. Okay, yeah. Yes?
When you say between -1 and 1, do you mean on the x-axis or the y?
Why? The function value, or the derivative values, yeah. So this is the f prime of x-axis. We're graphing the derivative. This is the x-axis. Yeah. Okay, good question. And that's just a few things about that. We actually used this example the other day to this one here. Oh, I'll just undo that. We used that, I took that picture from our examples in 3.2, just to talk about them some more. Okay, then there's a rule. And I only have a little bit of stuff to do on that. So, let's go for it. There's a bit of work to do with this one. Product rule, though. Find the derivative of each function using this product rule and simplify your result. A. Oh, I only have A now. I took out the other. Just do A. Now, the other day we said just distribute, and it actually in this case would be easier, but I need you to learn the product rule. Okay? So here's what we're going to do. I'm only going to rewrite this just so that you can see my color coding, okay? I'm not doing anything different. So I'm going to use blue first for 3x squared. And I'm going to use green next for 2x to the 4 minus 4x cubed. Okay. Now, find the derivative of each function and simplify your result. Just for time reasons, I'm going to skip the simplifying part. It's algebra. Okay. This product rule, though. Apparently, if you have a function that's multiplied by another function inside, that looks like what we have here and here, doesn't it? You can take the derivative of the first thing, leave the second thing alone, then add that to the first thing left alone, derivative of the second thing. Does that make? It'll make more sense as we do this rule, okay? It might not make sense. So dy by dx is equal to According to this rule, f of x, the first thing you do is take the derivative of f of x, f prime of x. So the derivative of what I have in blue is 6x. Derivative of the first thing, 6x. Then, leave the second thing alone. Leave the g of x, what I put in green. So I'm not doing anything to it. This plus sign is built into the formula. The next portion of it then, leave the first thing alone, do the derivative of the second thing. So the first thing left alone is still 3x squared. I'm only putting it in brackets just so you could see where things came from. You don't need that 3x squared in brackets. You didn't need the blue 6x at the start in brackets either. The derivative of the second thing, though. The derivative of 2x to the 4 is 8x cubed minus 4 times 3, so 12x squared. Okay? Now, we'll skip the simplifying for this. You should know how to algebraically multiply some things out, collect like terms, etc. There's a number of ways you could do it, but I'm going to leave it for now because that's algebra. It is tricky, and we've worked on factoring and stuff like that, but we'll leave it for the moment, okay? Because I need you to focus on the algebra a little more. The derivative of the product of more than two functions. So if I had three brackets going on, three things multiplied, do you see how this is just an extension of the rule? Now, f of x, g of x, h of x, three things. You can write it out this way, but it gets kind of sloppy, okay? But let's just take a look in a more compact form. All it is skipping the of x part. This represents a function, g then, and then an h. You see, it's still do the derivative of the first thing, leave the others alone. Do the derivative of the second thing, leave the others alone. Do the derivative of the last thing, leave the first two things alone. I think you could probably even extend that if you had 4 brackets, etc. You won't, if you did. Okay? It's really the same rule, just keep working one by one. But the main thing is leaving stuff alone when you're not operating with it and adding each time. So use the product rule to determine the derivative at -1 if, and then we've got 3 things, right? I'm going to use the same color coding as up here. Blue, green for G, and H. Now you don't have to actually think of F, G, and H. It's only just first, second, third, and so on, right? You just tend to use those letters. And the reason why I say that is some people, well, what about this f of x? That's a notation f of x. It's not to do with this. Okay? Back to here then. So the derivative, I'm going to work out f prime of x equals the derivative of the first thing, others left alone. Well, that's 3x squared, I hope, right? The other two things left alone, so 1 minus 2x. You can tell right away I'm going to run out of space, so I'm going to just go right there. You guys probably can fit it in. 3x minus 1. Added to derivative of the second thing. The other two things left alone. So x cubed left alone. The derivative of 1 minus 2x is -2. The 1 disappears. And then 3x minus 1. Add that to the first two things left alone, derivative of the third thing, x cubed. 1 minus 2x left alone. The derivative of the third thing is just the number 3. 3x minus 1's derivative. Okay? That only is about to begin. Now, what? We've got to do some arithmetic. Use the product rule to determine f prime of negative 1. Okay, we just need to plug in negative 1 into each one of these. So, f prime of negative 1. Now, some of you are pretty good at arithmetic. You could do this in your head as you just scan through it. It's a lot to keep track of. I'm going to just do it I'm going to jot it down as I do it. 3 times negative 1 squared is 3. Double check my arithmetic, guys. Green. 1 times minus 2 times negative 1, so it's actually 1 plus 2, so it's 3. Negative 1 times 3, so negative 3 minus 1 is negative 4. Now, working it through and so on. Negative 1 cubed. Negative 1. Minus 2 is no variable attached, it's still minus 2. And then negative 4. That's a 3. You could do this without a calculator. 36. 3 is 9. Negative 36. Minus 8. The signs are all I'm going to screw up on. Minus 9. 53. It's all negatives. Negative. 53. Now, sure you have your calculator. You could use it, but get used to doing some arithmetic without your calculator. Then what? That's f prime of x. So that means the slope at negative 1 for the original function is 53, negative 53. Because then it says, and find the equation of the tangent line that passes through the point. So we know what the slope is at x equals negative 1. Right? The slope at x equals negative 1. But that's not enough to come up with the tangent line. We need a y value first. Is that given? No. But we could use it in the original function. Y value question mark? Here's what I'm saying. Well, we put it in. F of negative 1 is equal to, well, negative 1 cubed is negative 1. 1 minus 2. Oh my goodness, here. It's 3. Yeah. Negative 4. That's equal to 12. So, negative 1 comma 12 is the point. We have a point, we have a slope. Point slope formula. Y minus 12 from over here equals negative 1, no, negative 53. X minus negative 1 was really x plus 1. There you go. If you toss that 12 onto the other side, you have an equation. It didn't state it had to be. Right? That's an equation solved for y. Actually, what you have initially, y minus 12, is an equation, but typically they'll say an equation y equals f of x, or like a function of x. So To be on the safe side, move your 12 over always. Have it isolated for y. With me, you'll want to have it isolated for y. Okay? And that's that. Beauty. Yeah. The calculus isn't that bad, though. The only step that was calculus was the first step, f prime of x. It's long. The rest was arithmetic, really. And then slope of a line, stuff like that. One other little thing, and then I got some stuff for you. Now, one of the assigned questions I have for you is from page 124, 24A and B, but if you can do these, I want you to be able to do this kind of a question. So page 124, I have it up here too, but how does this work? Suppose u and v are functions of x. It's from the textbook. If you can't read that, that's fine. It's in your textbook. That are differentiable. We're just told they're called u and v, though I don't know if it's x squared plus 2 and the other one's 3x minus 5 or something. When x equals 0, we know the function u gives us a 5, and the derivative is a negative 3. The function v gives me a negative 1, and the derivative on the function v is a 2. Find the value of the derivatives at x equals 0, and it went on from there. You might be saying like, what? I don't know. Let's try this out. So, move down a bit. All I know that u and v are functions of x. It could be 3x squared minus 2. It could be 2x plus 17x squared minus 8x cubed. But it doesn't matter, because we have enough information here to solve it. So, according to the rule, when you have two portions of a function, a product, being multiplied, right? What is that going to give us? We're doing the derivative of u times v functions. You take the derivative of the first thing, leave the second thing alone. Now this is where it gets weird for people. Like, what? So if I say the derivative of the first thing, I'm saying u prime. And the second thing, left alone. Add it to the first thing left alone times the derivative of the second thing. Okay. I just use that instead of f's and g's, right? Is that much different? It's just you're not used to seeing things without numbers. Well, then what? I'm supposed to evaluate it at x equals 0. So I'm going to just go at 0. Well, you guys know what to do next? At x equals 0, this expression becomes so u prime at 0 is negative 3. I heard this. Yeah. We've got, I guess I could say 0 colon. I guess we don't have a name for this expression, so like f of x or whatever. But whatever. Anyways, at 0, we've got a negative 3 times the v expression, negative 1, plus the u expression is the number 5 at 0. The v prime expression is 2. And that's just arithmetic. Negative, negative, so positive 3 plus 10, so 13. That part is no? Okay. So really like f prime of 0 equals 13 is what you've discovered. If we gave this a name. It didn't have a name, so it didn't put f prime of 0. So here's what you guys got to do. You're like wondering, what's this?
Hey.
What?
Is that Prince?
Oh, it's you.
So happy right
Okay. You're darn tootin'. Anyways. There's not too many. I know you don't have a lot of time. But try 13, 24 AD, 39 and 40. Okay?
You get that?
You're the first. I just looked on the webpage quickly for some pictures of somebody, and I recognize you from the honk or whatever. That's funny. Just like square. Anyways, I was looking for somebody who complains the most in my class. Oh yeah, that's him, for sure. Anyway, then